let's go ahead and get started. The agenda for today, we're going to review Lab 2 to start, and then we'll talk about color basics. Color is actually one of my favorite topics in data viz because it's something I think a lot of people kind of take for granted. It's sort of like, oh, just do whatever colors I like best, right? And you can do that, but there's lots of, I mean, color theory itself is a really complicated topic, and we won't get too far into it. But it's a lot more difficult, I think, than just choosing which colors you think look best. Okay. Then we'll also end up talking about ways to sort of diagnose your plots. I don't really have this in here, but to make sure that they're working well. And then we'll talk about common problems with color use. And we'll talk very quickly about some different options for palettes. There's a whole bunch out there. There's way more than I could cover in slides. And then we'll do lab 3. Okay. So we are looking at the 538 data, right? Let me bring that up also. Hang on. Thought I had it open here. Okay, so we're looking at this 538 story. Let me switch my second. Okay, looking at this 538 story, right? And then we're trying to replicate some of the plots for it. So the first thing I asked you to do is start with the Google Trends dataset, and then we're going to visualize the change in trends for each hurricane over time in one plot with 3 scales. Okay, so if we go back to R, can you all see that on Zoom? Probably not. Huh? It didn't seem to work like I was hoping. Whatever. Okay, so we're going to load the data, the different data sources, 538 and 538 data. Then we're going to load the tidyverse. And then this, I typically always use theme minimal as my sort of base plot, and then I add to it from there. This 15 is saying the base size is 15, so that's going to increase the size of the font a little bit. And so then we're going to look at this Google Trends data set, okay? And it looks like this. We've got the date, and then we've got Hurricane Harvey, US, Hurricane Irma, US, Hurricane Maria, US, and Hurricane Jose, US, okay? And so I don't want separate columns for every hurricane. I want one column denoting what the hurricane was, and then a second column that denotes the interest in that hurricane on the Google Trends, okay? So I'm going to do pivot longer. I'm going to say grab all the columns that start with hurricane, okay? So that's all of these except date. I could also say minus date, right? There's lots of ways to do this. I'm going to say these old names are going to go to a column that I'm going to call hurricane. These values are going to go to a column that I'm calling interest, okay? I've also, and this is a little more advanced and not something I would have expected you to do necessarily, but I did want to show you. I'm using this names pattern to extract the bit I want, okay? So I'm saying there's going to be an underscore, and then I want everything in from there after the underscore until the next underscore, okay? So this is that regular expression stuff that we talked about during strings a bit, okay? So these parentheses are sort of denoting where we want to have the extraction. And then remember, the dot is any character and the plus is any number of times. So it's saying take all the stuff between these two underscores, okay? So when I do that, I get a data set that looks like this, okay? And the names are all cleaned up for me already, except I actually want them to be in title case. So that means the H and I and M they're all going to be capitalized, right? So I'm just going to mutate that and say string to title on hurricane, and then it looks like that. Okay, so there we go. Now that's all cleaned up and I'm ready to go. So for the next thing, I need to visualize the trend over time using 3 scales. Okay, so I'm going to put date on the x-axis, interest on the y-axis, and I'm going to color the lines by hurricane. Okay, so I do that and it looks like this. Okay, let me pull this out so it's a little bigger. And then with my share, I will share both of them. Okay. All right. So then it looks like this. Okay. That's a basic plot, and that's cool. All right. then the next thing we were going to do is visualize the same thing except with solid shapes, okay? So the way I'm doing this is I have date and interest on the X and Y axis still, but instead of using geom line, I'm going to use geom ribbon, okay? And on the Y min, I'm saying that's going to be 0. I could also say negative inf, meaning negative infinity, but actually I really want it to stop at 0. So Y min is 0. Y max is my interest. That's the lines, right? And then the fill is going to be hurricane. So we're going to have different fills for the hurricane. I'm saying color is equal to null because that's going to be the line, right? I could change that to something else if I wanted to, but I did not. And that probably actually shouldn't be in the aesthetic. I don't know why that is there. It should be out here. Okay. So we'll do that. Nope, that didn't work. Okay. We'll do it back in there. All right. So then that looks like that. Okay. And if I wanted to, right, I could say color equals hurricane as well. And then that would look slightly different. Okay, not that big of a difference though. Okay, the next was we were going to do a heat map. So I have date on the x-axis, hurricane on the y-axis, and now I'm going to use geom tile, and I'm going to say fill is equal to interest. Okay, and I'm saying color is grade 90, so the color is going to be the outline of this squares. All right, so I do this, and I get something that looks like this. All right, that's not too bad, but I'm going to change the fill. Okay, so I quite like this Sicko library. It's by Thomas Lynn Peterson, who does a ton of really good stuff with ggplot. But this is a palette called Devon, all right, or Devon, I don't know which. So that looks like that. And then I tend to, so this is a different version using scale fill viridis, right? I tend to, for heat maps, I like to use chord fixed because I think it just helps when everything is sort of like each square is a square rather than a rectangle. And then I'm adding some additional stuff here. This is all like, basically, if you did this part, right, you'd be good. That's all I asked for. But I'm adding a bit of extra stuff just because I like it. Okay, so I'm saying I want the legend position to be on the bottom, and I want the legend direction to be horizontal instead of vertical. Usually that's going to be not a problem anyway. It's going to do that by default, so I don't know why I added that. But then this legend key size, this is going to stretch the legend, so it's going to be longer, and I'm changing the height of the legend as well. So I do all of that, and it looks like this, which over here looks like that. Okay, so that I think is a pretty nice plot. There's still some things we could do to clean it up, but I'm pretty happy with that for a pretty quick plot. Okay. All right, then the next thing I asked you to annotate it with vertical lines, and I told you to create a data frame to do this, right? So this is how I would do this. All right, I'm using from the Lubridate package, the MDY function. That means month, day, year. Okay, and then I'm just putting strings in here I'm putting 4 strings in here that are my 4 dates, and I'm putting them in that format: month, day, year. Okay, and then it's going to automatically figure that out for me. So I can run just that, and you can see it's transformed those into actual dates now. Okay, and I guess there's only three of them, not 4 of them. But okay, so that's going to be my date column, and then I'm going to add a column for hurricane, which is just going to be the labels for each of those. So I create that. Oops! Oh shoot! Stop. Oops! Wrong button. Okay, well, whatever. This is later stuff. I accidentally hit the button that made it run everything. So landfall is just a data set that looks like this, right? We've got a date column and the hurricane column. Now I'm going to go back to my plot. This is all pretty much the same, right? This is my using geom ribbon. But now I'm going to add geom B line, which stands for vertical line, right? And I'm going to say AES X intercept equals date, okay? But notice for this specific layer of my plot, I'm swapping out the data. So instead of using G, which is my Google Trends data, I'm using that landfall data that I just created, okay? So I can do that, that looks like this. And that was pretty much all I was asking of you. However, if you wanted to go ahead and add labels to it too, you could use geom text. There's other ways to do it as well, but geom text is pretty easy. Where we're going to put date, Y, and then we're going to say label equals hurricane. This Y equals 80, that's just what I decided to put it at. So you can see that's going to be about here-ish, okay? But you can put it wherever you wanted. And then I have this nudge X equals 2. That's going to shift it to the right a little bit, okay? So when I do that, we end up with something that looks like this, which is more like that, okay? And then finally, I'm going to add some labels. I'm going to change the color. So I'm going scale fill Brewer here, scale color Brewer. And notice I have hurricane here. That's going to change the name of the legend over here. So instead of being lowercase, it'll be uppercase. And then I'm saying I want the set to palette. And then I'm just changing the grids in the background a little bit and the text color and some other stuff. So let's see what this looks like. Oh yeah, so this is like my dark theme one. And this is an example too, where aspect ratio really matters. This doesn't look very good like this, right? But when I save it in my specific size that I was working with, then it all looks really good. Like for example, this is cut off here, right? Which is not good. But when you save it, so there's ways I'll show you later. There's like this GG preview function that you can write that's pretty easy to write. So you can say my plot that I'm going to end up outputting, I want it to be 6.5 inches wide by 8 inches tall, which is going to fill up basically a standard Word page document, right? And then you can keep rendering your plot and previewing it in that form, which then helps you understand what it's going to look like when in its final version. Because again, this doesn't look good here, but it does look good if you actually save it in the formats I have it in, whatever it was. Okay, so the next thing now we were gonna try to replicate that plot. So let's go back over there real quick and look at this again. So let me get there and then I'll switch my share. Oh, wait, it was this one. Okay, so let me switch my share. Okay, so this was the plot that we were trying to reproduce, right? And I said, I tried to be as explicit as I could with this, that it did not have to match exactly, right? It should match as well as you can make it match, but I would hope that none of you spent like 5 hours trying to get everything exactly right, okay? Close enough is good enough. I would say for the colors, there's a lot of different ways to get colors from things. My favorite is my favorite is a program called Color Slurp. Okay, and it just looks like this. It's free. I guess it's only for Mac, so there's probably equivalent ones for Windows. But what's nice about this is I can. So let me get Color Slurp going, and I'll show you. So I can change the colors here and whatever, but hopefully you'll be able to see this on Zoom. If I just hit Command-Shift-M, I get this thing that looks like this, right? And it will just tell me the colors. And then I just click the button and then it gives me the hex code for that color. Okay, so that's pretty neat. I actually use that all the time. It's a nice way to, but again, if your colors are, you know, orange, pink, and teal or something like that, that's fine. It didn't have to be exact. Okay, so back to our okay, so we were using the TV states with this one. The data looks like this. Let me scrunch this down. Okay, so we got date, Florida, Texas, Puerto Rico, right? And I'm gonna pivot longer again. This time I'm just saying minus date. So I want the old names are gonna go to a column called state, and the values are gonna go to a column called percentage. And then I'm making state a factor because I want those states to be, when they layer, I want them to be layered in the correct order, okay? So I'm making them a factor where the levels are Florida, Texas, Puerto Rico. Okay, so after I do that, it looks like this. Date, state, percentage, right? And this is a factor. And now I'm gonna, so I did end up going pretty far on this one to try to make it match. But again, that was not the expectation for you. For the state labels, I'm saying the state label is Texas, Florida, Puerto Rico. And then the dates, here's the dates, right? And then I put the percentage on each of those, which is actually, the percentage is really just where I want it to be, where I want the label to be vertically. So those could be anything, anywhere. That's just where I thought they looked good or as close as I could get it to the other thing. Okay, so this is another data set now that just looks like this. And then I finally created another one, which I'm calling Landfall 2, which is similar to the last one we had, the just one landfall. But I've also got the Las Vegas shooting in here. And notice for each of these, I have this /n. That's going to be a line break. Okay, so it's going to bring landfall underneath Harvey. Okay, so I have landfall 2. And then I'm going to use library extra font because I'm apparently changing the font. Yeah, I changed the font to Roboto Black, which I think I looked at the source code to find that online. But then, so now we're going to start actually doing this. I'm going to go geom ribbon to start, fill by state, y-0, y-max is percentage, color is white. Okay, so let me zoom here. And then I got to switch my share again so you all can see this. Just give me a second. All right. Okay, so this is what it looks like so far. And notice specifically, again, Florida is in the furthest background, then Texas, then Puerto Rico, right? That's how the actual figure was. And that was why I made it a factor with those levels, okay? All right, then we're gonna do geom V-line. Notice I'm changing my data to landfall 2 here, right? And then now we get those 4 different vertical lines, okay? And then I'm going to do geom H line at the y-intercept of 0. And the reason I do that is that just gives me a black line down here, which is similar to what they had, okay? Then I went with this shadow text, okay, which is a library that basically creates like big bold letters with outlines on them. And that's because that is basically what theirs look like, okay? So notice here, this is where I'm using that state labels data set, okay? And then I have the label as the state label, and then the color is black, that's the color of the text. The background color is white, so that's the fill of the text, basically. Family is Roboto Black, and so that ends up looking like this. Okay, see how they have that white outline? And none of this is like expected. I didn't expect you to do this. We're walking through this, so now you can see a way to do this, right? And it's not the way, it's a way, right? Okay, then I'm gonna go geom label to get our labels on what these vertical lines are. And so I'm doing landfall 2 again, color is white. This is kind of weird, but when I do this, it actually just gives me a white space for them. So the text is there, but because the text is white and the background is white, it ends up just giving me a white space where I want it to be, because I'm using geom label versus geom text. Okay, so geom label gives you like a label spot, and geom text does not. Okay, so that gives me the white space, and then I actually add the text on the next line. Okay, and they go right where they were. And so I did that because I didn't want the text to be sort of impeded by the grid lines in the background, right? Or the vertical lines. And again, that's similar to what theirs look like. And then I'm going scale fill manual. Again, I got these colors through Color Slurp. And there they are, okay? And then this part is a little bit interesting, right? I want to change these percentages because if we look back on that one, it goes 0, 1, 2, 3%, okay? So what I'm gonna do is I'm gonna do scale Y continuous. The name of it is gonna be share of sentences. The breaks are gonna be 0, 1, 2, 3. but then the labels are going to be 0, 1, 2, 3%. Okay. So we have the breaks, which are where those lines are going to be, but then you also have the labels for them. Okay. Then we're going to do scale X date. So I'm putting the breaks at where they had the breaks. And then notice I'm putting the labels just like they had the labels. And then I have this expand option, which is going to change where they're at here vertically. Okay. So do that. And there they are. Okay. So you can see this is kind of shifted over. Right. Almost there. I'm going to say guides fill equals none. That's going to remove the legend. Okay. So now the legend is gone. And then add the title. Okay. And then put the title in the middle, and then remove the minor grid marks, change the rest of the font to Roboto black, and then change the text on the axis to be gray 80 and size 8. Okay, so we do all of that, and there we are. So it's not perfect still probably, but it's pretty close, right? Like I'm pretty satisfied with that. Yep. Yeah. Yeah, so you can add a caption with caption, but to get the 2 different font sizes, you'd probably have to do something a little more hacky, basically, which would be probably you would want to annotate. So there's an annotate line, right, where you can add text to anything. And so you'd, again, probably want to get it in the size that you're ultimately going to output it at. And then you just kind of play with the X and Y values of the annotate until you got it to where you wanted it to be, and you changed the size to what you wanted it to be. Any other questions? Yeah, so where you can learn what the font is. Yes, so let me switch my share here. I don't know if I did this here or not. I can't remember. But you can always, if you have like Google Chrome or whatever, you should be able to go to View, Developer, and then Developer Tools. And then from there, you can do things like, you can click this little, this is too big. You can click this little icon thing here, right? And then you can click, so this is just an image. But you can kind of look through this here, right? We could see there's an ESPN footnote link, right? Or the other thing you can do is just go View, Developer, View Source, and then you can look at it this way too. And so what you'd probably want to do is go like family. So this one is Atlas Growth Helvetica New. So this is like the main one, but I don't know what that's for. So I may have just actually guessed at the font. I'm not sure. There are tools to help you with that as well. So Cassie is asking if anyone else had success in getting Puerto Rico color to stand out in the front. Cassie, do you mean just getting Puerto Rico to be the front one here, where like Texas is behind it and Florida is behind that?
Yes, you answered it. It was the factor thing. I didn't do the factor to get it.
Yep, that is what it is. It's the factor level. Great. Okay, so then the last thing we were going to do is look at our comic characters data set. And I just asked you to create some plots, right? And I didn't tell you, I didn't really give you any additional guidance other than that. So you could have done a bunch of different stuff. So the first thing I did is I created some percents. So I took my comic characters, I said count sex, so count how many there are of each sex, and then mutate to compute the percentage of those.
Daniel, we're not seeing your screen.
Sorry.
It's okay.
All right, so it's like this, right? Comic characters, count sex, and then mutate. Percent is equal to sum of n times 100. So all of this times 100. All right, so then we can see that, right, female was about 25%, male was about 70%, and then about 4% were missing, and then other categories were very underrepresented or very lowly represented, with agender being probably the most prominent, about 0.2%, which is still very low. Okay, so then we wanted to visualize these. So this is my percents data frame, right? And now I'm going to put x equals 1. So I'm just saying, just put them all at the same spot, and then y equals percent, and then use geom call where fill equals sex. So what this is actually going to do is it's just going to do a single stacked bar chart that looks like this. Okay, so is this the greatest chart ever? No, but what it does, I think, communicate pretty quickly is that most characters are male, followed by female. And you can see there's a lot of other categories here, but you cannot really even see them on the plot, right? So that shows pretty clearly that there are not very many. Okay, we could do the same thing, except do chord flip. That's kind of a cheater way to get a second plot. Not really cheating, obviously. Another thing that you could do that I like is to do a bar chart, but then to add the actual labels on them. So, so here I have percents. I'm going to factory order sex by the N, and then on the Y I'm going to put the percent, right? And then I'm going to put geom call where I'm saying position is equal to dodge, so it's not going to layer them on top of each other. Okay, so this is basically what it looks like. We have all of the different genders, and then they're ordered according to their N. Okay, I'm going to go chord flip on that. I could have just put the axes differently. And that looks like this. Okay, and then I'm going to do scale Y continuous expand 0.4. So again, I've talked about this, but these tend to be pretty far spaced out. And so I like to put those closer like that. Okay, so that's what that expand thing is. Okay, then we're going to do geom text. And I'm saying the label is as.character round percent to percent. Okay, and then I'm going to nudge Y 2. So that's going to nudge it off of the actual thing a little bit. That looks like that. Okay. And then guides fill equals none, captions, etc. Okay. And then we end up with something that looks like this. This is still actually not great though. These are overlapping too much. I don't know why I did that. I probably should have pushed this one down and made it white. I could have pushed this one down and made it white, and then had the rest of them out. So maybe I'll revise that when I push it up to GitHub so you can see how that looks. Okay, so that was all I had. And then, you know, that last part was very open-ended, so you could have done a bunch of different stuff, some of which was probably very different than what I did. Any other questions, comments on any of that?
Daniel, can we go back on the top?
Mm-hmm.
I wonder why we need an interest column.
So hang on, let me get there. You're talking about here, like with G, we make this column interest?
Yeah.
Yeah, so the reason is because our Google Trends originally, right, has separate columns for each hurricane. And that's not really what we want for plotting. We want a column that says what the hurricane is, and then a column that says the values for that hurricane. The values for this hurricane are the interest, right? But so that way we can say when we make that transformation, our data set now then looks like this, right? Let me pull this out a little bit. Then we have the hurricane, the date, and the interest. So then when we're doing the geom line, we can say we want this date on the x-axis, but then we want this interest to be our y-axis, right? And that column didn't exist before. And then we want them colored according to the hurricane, which also didn't exist before. Does that make sense? So then that is how we create this. And there are ways that you could create this same plot by keeping them as separate columns, but this is much more efficient to just transform the way that your data looks to start. Does that answer your question?
Yeah, thank you.
Yep.
And also, I wonder where you attached your demonstration on website, on Canvas, or?
Yeah, so I haven't yet. So the way that this is always going to work, right, is I assign the lab, you all do the lab, and then we go over it in class, and then after class, I push it to GitHub. So if you just pull from GitHub, you'll have the R Markdown, you'll have this exact R Markdown file that I'm working on right now. So we've already reviewed lab 2. All right, so now we're going to talk about color for basically the rest of the day, okay? So we'll talk about different color palettes and why some might be better than others for specific reasons. And then what I really want you to do is to think about color in a deeper way than you maybe have previously. And specifically, if you create a plot, you should be able to evaluate how that plot would appear for people with various kinds of color blindness, okay? I'll show you a couple of different ways to do that. And then hopefully this isn't too far out there for most of you, but we should, by the end of this lab anyway, be able to pretty fluently apply different colors and fills to plots. And so, you know, that's going to be scale color or scale fill, unless you're just changing the actual thing globally, and then it's just going to be color equals outside of the AES, right? So whenever you're using AES, so whenever you're mapping a variable to color or mapping a variable to a fill, then you're going to need to use scale color whatever or scale fill whatever to actually change those colors, okay? If you're not mapping it to a variable, then you don't have to use those functions. It's also important that you keep straight the color and the fill, right? So most things, the fill is going to be the like inside of it, and the color is going to be the outline of it, essentially. And then the other thing is, we'll talk about this a lot throughout, but really, as I've tried to say to start, color is a much more complicated topic than it seems on its surface. So really, you should be trying to use the advice of other people who really study this stuff and use their palettes, okay? Sometimes you can create your own palettes, and that's great, but very regularly, I would suggest using other palettes that already exist and have some evidence that they actually work well, okay? So a couple examples of why color choice matters. This is a image, right? Using like this green-orange palette. It's like the terrain colors palette or whatever. So this is what it looks like with this palette. But if we just switch to a gray palette, you can see much, much more detail, right? The difference between those is pretty staggering, right? And that same sort of thing can happen. I mean, that's just a color change, really. And that same sort of thing can happen all sorts of different ways. Okay, one more quick example like that. There's a package called Ray Shader. It's created by Tyler Morgan-Wall.
This is Hobart.
This is him, and apparently I was too far, but we're gonna watch just a minute of this, of his presentation on this, on Ray Shader.
Control over their appearance. So this is what happens when you plot elevation data with base R using the image function. The code is on the left and the output is on the right. This is Hobart, Tasmania, but looks more like two amoebas dueling it out in pond scum, or as base R calls it, terrain colors. Here, the Hobart object is nothing more than a base R matrix. Here is the Ray Shader version of that plot using spherical shading. It's a much more naturalistic view of the data. While you lose the direct mapping of color to elevation, you gain a much more...
All right, so I want to just pause there for a second. That's the same thing, right? This versus the other one are the same thing. And really all that has changed is the colors in it, right? But it's a dramatically different picture.
Human understanding of the landscape's contours. Note how details appeared that weren't apparent in the base R plot, namely the fact that there is a river between these two mountains. Ray Shader is built around elevation data, and building a plot works similarly to how you build a plot in ggplot with layers. Here, I've added a water layer simply by calling the detect water and add water functions in RayShader with the elevation matrix. This overlays a water layer on top of the sphere shade layer. Now, RayShader's name comes from the fact that it uses ray tracing to shade topographic maps. So much like we added our water layer here, we can add a shadow layer simply by calling the add shadow function with the RayShade function. This traces rays from each point on the elevation matrix, determines if that point is in shadow or light, and shades it appropriately. The add shadow function layers it onto the existing plot, passed in using the pipe operator. We can continue stacking different types of shadows with additional calls to add shadow. Here we add an ambient occlusion layer, which models atmospheric scattering and makes valleys darker than ridges. We now have, in my opinion, a beautiful 2D topographic map. But if you think about it, our data is already inherently 3D, X, Y, and Z elevation. So in RayShader, transitioning from 2D to 3D is as simple as swapping out the plot map function with the plot 3D function.
All right, we'll pause there. But RayShader is a pretty amazing package, and you can create really lifelike looking things. And it does some really complicated stuff under the hood. But again, it's basically just different uses of color, right? So
note how the only data used to generate.
No, we're not going to note that. Okay. If you're interested in that kind of stuff, especially if you are doing any topographic stuff, I'd really recommend you check out that package, RayShader. It's really neat. Okay, taking a step back though, the way that we're going to use color most of the time, there's going to be three fundamental uses. Okay, one is to distinguish groups from each other. So, right, maybe you have gender and you have like male, female, non-binary, right? As your three groups, you could use color to distinguish those three groups, right? The other is you could represent data values. We've already seen this with heat maps, right? So you have like percentage or something, and the higher the percentage goes, the darker the color or the brighter the color or whatever. And then the third, we haven't really discussed yet much, but we will today, which is to highlight specific values. So maybe you have specific, states you want to highlight, or you have specific, maybe you have like some plot of all of your data and you want to highlight the points that were in the treatment, right? That's another way to do this. Okay, so we'll start out with color as a tool to distinguish. When we have discrete items, there's often no intrinsic order, okay? So if they're ordinal, then that's one thing, but very often we just have like qualitative things. So again, if we think of gender, right, that would be qualitatively different things. And so we want to choose a color palette that represents those things as different, okay? But they have to be equivalent on this in terms of perception. Okay, so for example, we have two colors. We want those two colors to be maximally different so that you don't interpret one as the other. But especially once we get to three colors, you don't want to convey any sense of ordering. Okay, so you have three colors. You want them all to be maximally different from each other, but you also don't want them to convey a sense of order when there isn't one. Okay, there's lots of different palettes that have qualitative palettes, but here's a couple of them. Okabe Eco is a really good one for color blindness. We'll talk about that one more in a bit. Color Brewer, Dark 2, and then from ggplot to just the base Hue one, not base, but ggplot Hue. And you can see with all of these, those colors all like within a row, right? They all look different, but they don't necessarily convey like an ordering effect. So one doesn't appear more than another one. So how do we use them? Well, in this case, I'm going to work with this population growth data set. Okay, and so it has the region, division, state, and then the population for different years. And we're actually going to look at the population growth, which is just the change from 2010 to from 2000. Okay, so over a 10-year span. So we're going to start like this. where I'm going to say, I'm going to use population growth. I'm going to put pop growth on the x-axis and the state on the y-axis. All right. And then I'm going to say geom call alpha is equal to 0.9 because I already did the factor reordering. They're ordered according to their population growth. Okay. So Nevada had the most growth and Michigan actually lost people. It had negative growth. Okay. So we could fill by region like this, right? We would say geom call AES fill equals region, right? So we're going to map to a variable, in this case region, and so we're going to put it inside AES, and I'm saying fill instead of color because I want the actual bars to be that color, not just the outline. Okay, here is that same plot with created according to three different kinds of color blindness, plus a desaturated version. So a desaturated is, you can think of it in terms of like, what if we were to print this in black and white? What would it look like, right? And so you can see it actually works okay for the two types of color blindness, or three types of color blindness, right? You can still kind of see some ordering like this. These are a little bit tough, but you can see them. This one's tougher because I think this one and this one are quite similar. This one works pretty well, but this one is like, good luck, right? The desaturated version just does not work well at all, okay? So alternatively, we can use a different palette that maybe handles those things differently. The Viridis palette is a very commonly used palette now. It became very popular about, say, 2 years ago, and now you'll see it all over the place all the time. And so this is the exact same thing as the last one, except I've said plus scale fill Viridis underscore D. Anybody know why it has that underscore D on it? Any guesses? Yeah, so D stands for discrete. Okay, and then the C stands for continuous. Okay, so I'm mapping to a discrete scale, so therefore I have underscore D. This is what that plot now looks like according to those three different kinds of color blindness and the desaturated version. So I would argue that all of these are better, right? This one looks pretty distinguishable still. This one's pretty distinguishable still. This one's more distinguishable. And even the desaturated version looks pretty good, right? It's not perfect. It's definitely more difficult than if you have the color, but you can see the differences between those still. Like specifically the Northeast is very easy to pick out, right? And this is maybe a little bit difficult because I have this white background and it's almost white, but you can see those differences. Okay. All right. Here is another version where I'm doing this. I'm using the same thing, but now I'm saying scale fill Okabe Ito. Okay, Okabe Ito comes from the Color Blinder library, which is a really nice library that you will need to install because we're going to use it during lab. Okay. This is links to an article about the Okabe Eco Palette. And so I think this actually looks pretty nice just on its own. But that's opinion, but it does work quite well again here for all of these. For the color blindness ones in particular, it works quite a bit better, I think, than Viridis, right? Because these are still very distinct, like super distinct for both of these. And this one is too, right? These two are a little bit similar, but they're distinguishable. The desaturated doesn't work quite as well as the Viridis though. So you'll have to kind of, balance what you're trying to do. If you have a good idea that people are going to be printing this in black and white, then Viridis is probably going to be preferable. Otherwise, Okabe Ito is probably going to be preferable. Okay, so how do I check for color blindness? Well, through the Color Blinder package. Okay, there were people I know last year that had difficulty installing this package. It's not the easiest to install. So if you do have difficulties with it, we'll look at some other packages too, okay? So, but the Color Blinder is, it depends on the development version of Color Space, okay, and Cowplot. So what you're going to do is you're going to do install GitHub Wokalab CalPlot, and then install packages color space. But notice you have to change the repo to this repo, and then install GitHub Color Blinder. Okay, so it's like 3 steps. And if you're running into errors, then you can do this. Okay, so there's another package called Color Blindness with a capital B. Okay, and this package is actually just built off of Color Blinder, but it's on CRAN, and they don't seem to depend on the other packages as well. So if you have any issues with the other one, then you can use this. Both of them will be able to create those grids like I just showed you. This Color Blindness one uses Cbd plot, and the Color Blinder one uses Cbd_grid. Okay. Okay, so this is how you actually create those grids. So here up at the top, I'm creating the plot, right? And then what I tend to do is at the end of the plot, after I've created it, I add theme void, okay? And theme void is going to remove everything except the bars, okay? And the legend. So you can see all the axes are gone, the grid lines are gone, like everything is gone basically. And I like that because I'm really just trying to focus on the colors. I don't really care about any of the other stuff in this, okay? Then you do Color Blinder Cbd_grid on P. So notice I saved my ggplot object here to P, right? And then I'm calling Cbd grid on P. Okay. Any questions on any of that? All right. So let's talk about color for continuous scales. So as you might guess, with qualitative scales, we want them to be maximally distinct. With continuous scales, we want basically the opposite, right? We want a very clear sense of ordering. And what's really important here is that the change in the color from one to the next needs to be consistent. So if the change from this blue to this blue represents, say, 5 points on our scale, then that difference of 5 points perceptually, right, needs to be consistent for all the way across the scale. So you shouldn't see these jumps that look like they're a lot more than they actually are, okay? And so through just those 2 things, now looking at qualitative and continuous, you're probably realizing, right, if you just pick your own palette, it might not actually have these properties that you really want to have. Okay, so here's a couple of different examples. We've got Color Brewer Blues, Heat, and then Viridis. Notice Viridis, so the blues and heat are, well, blues for sure, but heat somewhat too. They're single color scales, whereas Viridis is a multi-hue scale. Okay, so it goes from purple to yellow. And generally these multi-hue ones, they're going to try to mimic things that we see in nature in terms of like hot and cold and whatever. Okay, so sequential scales, these are all forms of sequential scales, right? Which ones are larger, smaller? How distant are the 2 values from each other? So I've already said all of this. So it's similar to an interval scale in terms of measurement if you have that sort of background, but for color. Often based on a single hue, but then we have multi-hue ones as well. Okay, so common uses for sequential palettes, heat maps, right? We've already done them a couple of times. Here I'm going to do a heat map from the diamonds data set. So I'm creating a data set called HM heat map, right? And I'm using this package core with 3 R's and then correlate. The reason I like this package is because it will then return a data frame, which makes it easy to then switch straight to plotting. So we're going to correlate, and then I'm going to just pivot longer to put it in different shape. And then I'm going to do some fact reordering. So this is what the data set ends up looking like that I'm trying to plot, right? We have the term, we have the name, and then we have the value. The value is the correlation, right, between these things. Okay, so by default, it puts the correlation with itself as NA, and so that ends up gray. Okay, so this is the default palette for this heat map. And I can change that by using a whole bunch of different things, right? But in this case, I'm using scale fill distiller, and I'm saying palette equals blues. So this is actually not exactly the same blues palette I showed just a little bit ago, but it's very similar, right? Just based off a slightly different hue of blue. So you can see they look pretty darn different, even though they're both like a blue palette, right? But one thing we might worry about here, and that you probably should worry about here, is the NA values, okay? And so for that reason, you might actually want to put these NA values at 1 if you're plotting a correlation matrix like I am. But in many cases, you don't have a value like that to place it with. And so you need to find a color for your NA value that does not correspond with your palette, okay? So in this case, I found a hex just through, I'm gonna show you another website I use a lot real quick. I think I might have showed you this before, hlspicker.com. And so what I would do is just find a hue, and then I would kind of mess with these. So this is the hue, right? This is the amount of color. This is the brightness of the color, the lightness of it, rather. Okay, so this is a very human way to think about colors, HSL. And so basically, I just kind of messed around with that until I found a color that I felt like kind of conformed to the blues, but was distinct from it, okay? And so I did that with na.value in my scale fill or scale color or whatever, okay? We can also use this to our advantage. So the core package has this shave upper equals false thing. So you can like put all of the repeats to NA. Okay, and so it looks like this using the default, right? But then I can change. Why is this thing being so slow? There we go. So I can change the default for the NA value to actually be transparent. Okay, and so here I'm using scale fill Viridis. Notice it is Viridis_C because I'm mapping to a continuous variable now. And then I have option equals magma. You have Viridis, magma, infernal, and plasma. And then there's actually more since that time. There's like Cbd, I think, which is actually a pretty nice one. So you could look at the documentation to see all of them because I'm just realizing now as I'm talking that I'm missing at least one. I think maybe 2. Okay. Chloroplasts are another really common use of these sequential palettes. So this is data that I just got from the census really quick and pulled for Lane County. The percentage of people identifying as white. I don't have the code printed in here, but you can look at the source code for the slides if you're interested. So this is the default palette, and I flipped it around so darker values end up being less. So this is like Eugene, right? And so you can see it's still very white, but it's a little more diverse than the rest of Lane County, which is incredibly white, right? So this is now looking at the same thing, but with a different palette. And so you can see it is highlighted quite a bit better, I would say, with this heat palette than with the blues palette. This is how we would create these. There's a bunch of them. This is with the Viridis palette. And then the other sequential types of palettes that we haven't talked about yet, but I think are really important, are these diverging palettes. Okay, diverging palettes are just like sequential palettes in that they have a uniform sort of amount change perceptually based on your values, but they also have a center point, right? So they have a balancing point. So this is really common for like political visualizations where you'll have a center point that's usually white or something around white, like a light gray. And then one side will be blue and the other side will be red, right? And these are called diverging palettes and they're really useful. So there's a palette that's a diverging palette called Earth, okay? And I have balanced this palette at 50%, okay? So again, this is the percentage of people in Oregon now by county identifying as white on the census, and it's all green because it's Oregon. So that's not very interesting. So let's look at a more diverse state, right? California now this is the percentage of people identifying as white, and you can see that you can see very clear geographic patterns there, right? As you go north, you have more people that are identifying as white. As you go south, you have fewer people that are identifying as white, right? Until you get to Oregon, and then it's just green. Right. Okay, so back to our heat map, our correlation heat map, right? We could use a diverging color palette here too, and this is a very common place where we do use diverging color palettes because we have a center point, right? 0 of no correlation. And so here I'm using scale fill continuous diverging X. Okay, this is a very long thing. We'll talk about this more in just a second where this came from. But I'm using this tropic palette, okay? I'm saying the midpoint is 0. The limits are -1 and 1. And I'm swapping the order. So I'm saying reverse the default direction of this palette. And then I'm putting transparent as the NA value. And that ends up looking like this. Okay, now, because it always gets screwed up here, maybe look back there and you can see better. There's these two here that are actually not missing, but up here they do look missing or pretty close to it, right? And so this transparent here might actually not be the best choice here, right? Because our center point of our scale is almost white. And if we're on a white background and we're saying make the NA values transparent, then these could look like values of 0 rather than values that are missing. So we could try a different palette. Some of them, most of these diverging palettes are going to be a light gray or a white for their center point. Some of them are not though. Some of them have like a black that is the center point. So this is one of them, Tofino. I think it looks not good at all. I don't like it very much. So we'll try it again. I'm going back to my tropic one, but this time I'm saying make the NA value gray 70, and that looks like that. So I still don't love it. It's not my favorite, but I give up for now. Okay, but you can see how you could kind of explore this stuff. Okay, so those functions, the diverging ones, come from this package called Color Space. Okay, Color Space, and it's linked in the slides, has an amazing number of palettes, and they have a ton of information in here to help you learn more about color as well. So if you go to the articles, they've got all of this different stuff, right? So we can see HCl-based color scales for ggplot2, and they show you just how to use them, right? And that's pretty straightforward. But if you go to just HCl-based color palettes, then you have a whole bunch of information on how these palettes are created, different types of palettes, and all sorts of stuff. So here's all of their multi-hue sequential palettes. Okay, so you can look through these and find one that you want, and then there it is, right? So like this one is called Perp, this one's called Perp Or, right? And then you would create these, and here's their diverging palettes. There's again a bunch of them. They have some background on the creation of them. So there's a ton of stuff, right? And then when you're actually going to use them, you would come here and say, you know, scale, field, discrete, qualitative. Or if you want a continuous one, scale, color, continuous, sequential, right? And so there's a bunch of them like that. Scale, fill, bend, sequential, right? That gives you a slightly different image than this. So it's going to actually bend. So it's taking the continuous palette, but it's actually bending it like this. Okay, and sometimes that can actually help get a clearer picture. Okay, let's come back here. Oops. Color Space also has a bunch of helpful diagnostic sort of things that you can do. So here I'm just saying, okay, give me 5 values from our tropic scale that we used before. And I'm saying rev equals true because we had it reversed before. So I'm going to make it reversed again. And then you can say demo plot on our scale. So this is creating a color palette with 5 colors from that tropic scale. And so I'm saying, give me a demo plot from our scale, give me a demo bar plot. Okay. And then it shows you 1, 2, 3, 4. You know, it's just a demo of what a bar plot would look like for that palette. Here's a demo for the heat map. Okay. This actually looks like it's that bend again. Here's a demo for an actual map. So this is like a Chloroplast. Here's a demo for lines. And there's a demo for scatter. Okay, sometimes though, the background color of your plot is not white, right? And so what you can do, this is all base graphics, the stuff that they're creating it on. So you have to kind of change things that way. But so you'll use this par thing, and then you probably just have to Google around to find it. But like BG means background, right? So I'm saying make the background gray 20. CEX is the size of the points, so make that 3. MAR is the margins. I had to do that to get it to fit on my slides properly. But you can see then this is what that palette looks like on a dark gray background. So actually, I think it looks even better on a dark gray background than it does on a white background. You can also do this HCL plot function for the palette, and it's pretty neat, I think, because it shows you the palette, right, according to the chroma and the luminescence. And then the hue is up here, which I don't totally get, to be honest. 325/196. I don't really get it. But this is the palette. And then those points on the palette show you where they drew those 5 values from to get the palette that they got. Okay. And then you can look at it slightly differently like this through a spec plot to see the different values of the luminescence, the chroma, and the hue. Okay, and again, there's much more information on all of these things in the documentation. I'd really encourage you to go look at that because it's really nice. You can also check for color blindness for just your palette through color space like this. Okay, so this just says our palette because that's just going to be whatever this is over here. But you say swatch plot, that's going to create one of those swatches for your palette. And then all you have to do is say Cbd equals true, and it will create the 3 types of color blindness plus the desaturated version of that palette. So you can just evaluate them very quickly right here by how they look across those. Okay, last thing on this, there's also this interactivity, which is pretty amazing as well. So they've basically taken all of this and put it into a Shiny app. So you can change what you want the example to be. I'll go with a mosaic. You can change the whatever color scale you want. You can change from sequential to let's go advanced diverging. And there's blue, red 3. Maybe instead I want this one, right? And then, but what is also cool is you can say, well, what if I want the dark mode? See what it looks like on a dark background, or see what it looks like in desaturated, or with the different types of color blindness, right? And then the last thing that I think is really neat is you can actually say, well, okay, I like that, but let me change this one down here and change that one there. And then I'm going to change this one up here. And then again, you can check all of these color blindness things if you want. But if you go to, and you can look at some diagnostics for these through the spectrum stuff, like we were kind of like we were doing before. There's the color plane for this one. That one's really bizarre. But when you go to export, you can actually go to R, and it will just give you the code to actually create that palette. And in this case, we're getting a custom palette that we have because we've modified these things. Okay, so that's a pretty powerful tool, I think, that the people who created Color Space have created for you. Similarly, there's this one that's a online Cbd emulator. I think this one is just kind of nice because you don't have to necessarily be in R to test for your CBD stuff. So here's an example of a plot that I created, and then I created a screenshot of it. All right. And then, so you upload an image of the plot, right? And then you can, again, check different types of color blindness, and you can just go all, and it will create them for all. And so in this case, it's nice because, again, you could take somebody else's image that they created using whatever, and you could upload it here and kind of check it and test it out for color blindness issues. Okay. Any questions on any of that? All right. So the next part is, next sort of fundamental use of color is to use color as a tool to highlight. This is one of my favorite things to do, and I think it's a really powerful way to take your visual from something that looks nice but pretty basic like this to something like this, where you're saying these are the compact cars, right? And all I've done here to highlight in this case, I have my geom point, right? So this first two lines are basically the exact same, except I've changed the color to gray 80. That's this light gray color. And then I'm adding another layer of points. So I'm adding layers on top of it, but I'm filtering my data to only the data that I want to highlight, right? And then I'm changing the color of that point to something else. Okay. So that's a really nice way to highlight specific points. You're kind of graying out the main ones, and then you're adding another layer with like a red or a blue or something that really stands out to highlight those ones. This is another one just with a different thing. We also, gosh, why does this keep happening? Okay, we also though probably want a legend, or we need some way to highlight that those red ones are compact cars, for example, right? There's a couple of different ways you can do this. One is you could just annotate it, right? So you could have a little line that draws to a point and then just some text that says compact. There's also some that are kind of like hacky, right? So this is a little bit of a hacky way to do this, but it works. So we have geom point gray 80, but then this, and then this. So everything up to here is just like we had before, right? Except this line right here, where I'm saying AES color equals compact. So I'm basically saying that I'm going to map the color to a column in my data set called compact. That column doesn't exist, right? But all of those points are just going to be that like pinkish coral color that's like the default. It's the first color in there. And so then you can say scale color manual and change the values of that color to be whatever you want. All right. And then the last part is you have to do some messing with the legend to get it to look the way that you want it to. But then it ends up looking like this, right? So we have the red points, and then we have a little legend that has a red point and it says compact. Okay. Okay, let's go back to our states plot for just a minute. So let's say we wanted to highlight Oregon and Washington, right? We're going to highlight the Northwest. So we have this whole part, just like we had before, population growth on the x-axis, state on the y-axis, and then we're going to fill by region, right? But then I'm going to add another geom call layer where I'm just filtering the data where population growth is Oregon or state is Washington, or state is Oregon or state is Washington. And then I'm going to fill with that same red color I think I used before. And then I'm saying plus scale fill Okabe Ito. So every other one is going to be filled according to the region, but Oregon and Washington are going to be this red color. Okay, and that looks like that. Okay, again, we'd probably want to do something to note why these ones are red. So I would probably annotate it right here with something that says like Northwest. I'd also probably get rid of a lot of these grid lines because they're kind of just getting in the way. All of these horizontal grid lines I think are not helpful. The vertical ones are, but not the horizontal ones. So we could probably get rid of all of those. And then, yeah, just have some annotation that maybe points to these lines and says Northwest or something like that. But another thing you can do is you can actually make the labels. Let me go back here. You can actually make these labels, Washington, Oregon, you could actually make those red as well, which will highlight, highlight those states a little bit more. So this is how we would do this. Okay, I have states. I'm going to get just the unique states. So states are repeated, maybe, I don't know, but we're going to grab just the unique states. Okay, and then I'm going to create this vector that I'm calling label color, where I'm saying if the states is equal to Oregon or the states is equal to Washington, then it's going to be this red color. Otherwise, it's going to be gray 30. Okay, so label color just looks like this. It's a bunch of gray 30s. And then we have one red there and one red there. And the rest of them are gray 30. Okay, I can do the same thing with my label face. So I can say if it's Oregon or Washington, make it bold. Otherwise, make it plain. And that's going to look just like this. It's going to go plain, 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 and then occasionally bold for when it's Oregon or Washington. Now that we have those, we can go to our theme and say the color is equal to the label color and the face is equal to the label face for axis text.y. Axis.text.y. Okay. And then that ends up looking like this. It's still a little bit small, but you can see Washington and Oregon there and they're red. Okay. That's like not the most important thing, but it's kind of neat. Even better, these other values are still like quite prominent. So we might want to sort of de-emphasize the rest of the values. And so we can do that like this. This is not my code. This is Wilke's code from his book. Okay. So what we're doing is we're taking our palette. We're just taking these values of them. Then we're going to desaturate it by 40%. Oh no, lighten it by 40% and then desaturate it by 80%. Okay, and then we're going to darken, that's for the first 4 values, 1, 2, 3, 4. And then for the rest of the values, we're going to just darken them by 30%. Okay, and so then this is what those swatches look like, which then when we create the plot ends up looking like this. Okay, so you can still see the region differences, but the Northwest is very clearly highlighted there and very prominent. Okay. One other thing we could do is use.
For the desaturated color version, can we just like select color palette that's contrast or something?
Yes, you could. This is just a little bit more manual way to do that, and yeah, desaturating and like this is it's not easy, right? Yeah. But if you can do it, it's gonna look nice, I guess, is the main thing. The last thing I wanted to show here for this specific plot is we can use this GG text library to add a subtitle where we're highlighting why they're red. Okay, so what we're doing here is I'm saying library GG text, and then I have everything else is just the same. But then for my labs, for my labels, right, I have subtitle, and then I'm going to say and then notice I have this like HTML code right here, right? I'm saying this span is going to be this color, okay? And then I have the stars, which are going to make it bold. And then I'm going to say, okay, now that's the end of the span, okay? So it says Northwest is where it's at. And then in the theme, you say axis text.y. Color is the label color. Face is label face, and then for the plot subtitle element markdown. Okay, so this element markdown comes from GG text, and then we get this. Okay, so now we finally have actually our label showing why those ones are highlighted. Okay, all right. Back to the cars plot for just a minute. So this is another way, before I showed you kind of the hacky way to get a legend on there for the points that were highlighted. So this is just showing you that another way we could do this is to use this same sort of thing, subtitle, span, color. That compact cars typically have small engines, right? And then plot subtitle element markdown, and then it ends up looking like this, right? Cars with bigger engines get lower miles per gallon. Compact cars typically have small engines. Yep. Yep, it would. You know, you would probably want to still check for like the desaturated version if you were thinking about printing in black and white and things like that. But yeah, it should work whether it's HTML or PDF. Other questions? Okay, last example for highlighting. This is a very different example, which is why we're doing one more, okay? So we're dealing with this sleep study data where we have the reaction time of people, and then this is the number of days they've been without sleep. It's just like a torturous study. But this is what the data look like if we plot them over time, okay? So we have days on the x-axis, and then their reaction time on the y-axis, and then we have different lines for each subject, okay? So that's why it says group equals subject. That's giving us the different lines for every subject. Because in this case, we don't want different colors for every subject. That would be too much, right? But we want different lines, so that's why we have group equals subject. Okay, now maybe I want to highlight anybody who had a reaction time greater than 400 at any point in the study, okay? A very easy way to do this is with the GG highlight package, okay? So I'm gonna load GG highlight, and then I have everything up to this point is just the same, but I'd say GG highlight, and then I just give it the criteria it needs to highlight, okay? So I'd say where the max reaction is greater than 400, and notice this line is above 400 there, this one's above there, and these are both above there. So we have 3 lines. It's going to print those ones in the black, and it's going to put the rest in gray. And it's going to add a label here to tell us who those participants are, okay, their subject ID. So that's quite a bit of work that it's doing for us pretty easily. We can also instead say color equals subject. And then when we do GG highlight, it'll have different colors. And then we can add our own color scale to that after the fact, okay? So in this case, again, because it's only 3 people, we're getting a color scale with 3 values. If you wanted, you could even facet wrap by subject, okay? And this is really nice. I mentioned this before, but I didn't give you an example, and we'll walk through a slightly different example of this in just a moment. But this is showing all of the data in the background, right? But then highlighting a specific case within each facet. So each facet, you have all the data, but you're able to compare one case to everybody within each facet. Okay, and I think this is super nice generally. One way that you can use this as well, which we'll go through here in just a second, is with distributions. So maybe, again, you have like, you know, different, like a treatment distribution and a control distribution. And for each of those, you want to show them relative to the overall distribution, right? And so you can do that by using the overall distribution as the background data, and then just sort of highlighting each group. Okay, GG highlight package is really neat. However, I've had issues with it in the past. Sometimes I think it should work perfectly. It seems very straightforward, very easy, and it just doesn't seem to work for me. So if that happens to be the case for you, you can always fall back on these more manual ways of doing it like we just did before. However, having said that, sometimes the manual ways are quite difficult as well. Okay, so here I'm going to show you one way of creating that same plot we just did, basically, but doing it more manually. Okay, so this is a little tricky. It took me a bit of time to figure this out. I'm going to start by just selecting cases that are greater than 400. Okay, so I'm creating a data set I'm calling high, where I'm taking all of sleep study and saying filter where the reaction time is greater than 400, and then select the subject. Okay, so that in that case, I'm going to have, if we go back here, right, like this participant has a couple of observations that are over 400, right? And that's fine. I'm just going to have that subject ID repeating, okay? But then I'm going to create this highlight data frame where I'm going to semi-join my sleep study data set with this high data set. Okay, any idea why I'm doing that? Well, it does drop the extra cases, but it's actually, it's because I want all of the data for each subject. Okay, so in this case, this is only giving me the observations that are greater than 400, and I'm trying to get the subjects who have an observation greater than 400. So when I semi-join it like this, that highlight data frame is going to contain all of the data for each of the 3 participants that have an observation over 400. Okay? So then I'm going to create another data frame, which this filter one I'm just using for the semi-join, okay? So HL, highlight, that's my real data frame that I'm going to use in my plotting. And I'm creating another data frame, which I'm calling BG data, background data, okay? And all I'm doing here is I'm just renaming subject to be ID, okay? And the reason is because we can't, well, we're going to be faceting, and we can't have a subject column in there because we don't want that background data to be faceted. We want it to be in all of them, okay? But I actually still need this ID column because I want separate lines by ID, okay? Okay, so finally, we're going to put it all together and plot it, okay? So I'm gonna ggplot HL, my highlight data, put days on the x-axis, reaction time on the y-axis. Then I'm gonna add geom line, but notice I'm adding geom line with my background data to start, okay? Because I'm gonna add the other lines on top of it. Background data is gonna be the first layer, right? Because it's in the background. And so I'm gonna say group is equal to ID, and the color is equal to gray 80, and the data is background data. Okay, then I just say geom line, color is equal to subject, and facet wrap by subject. Notice this facet wrap, again, will not catch any of this geom line in the facet wrapping because there is no subject column there anymore. Okay, and then finally it looks like this. Okay, and so I could continue to modify it from there, but that I don't really want to, at least at this moment. I just wanted to show you how to do that more manually. And part of the reason why I wanted to do this is because I mentioned before that I find stacked histograms to be hard to interpret, right? And so I've said before, one way to do that is just to facet wrap by them instead, right? But sometimes that is less than ideal too, because you want to be able to view the distribution for that group relative to the whole, which is kind of why you need that stacked histogram. So instead, I can do this like this, where I'm creating everything like I did before, right? I just have depth on the x-axis, fill by the cut, and then facet wrap by cut. And then here, I'm just adding an additional layer, right? Where I'm saying select from diamonds minus cut. Okay, cut is that variable that I'm facet wrapping by. So I'm just dropping the variable that I'm going to facet wrap by. And then I'm going to say fill equals gray 80. And then the rest is the same. And then it ends up looking like this. Okay, so I think this is super nice. And I don't see this used all that often, but I think it's a really good approach to show the data for a group, but be able to compare it to the full distribution. Okay. All right. We have just a few more minutes here, and then we'll switch to the lab. Okay. Last couple of things to consider. Okay, double encodings. This is what I was mentioning earlier that I thought was last time, but it's actually today. Okay, so this plot is a little bit less than ideal, just because when we're thinking about different types of color blindness, you can distinguish for the top two pretty well. This bottom left one is pretty tough, right? These two are pretty hard to tell, and then this one doesn't work very well. And that's with using Okabe Ito already, right? So for these two, it's pretty clear, but this one's not very clear. So what we can do instead is we can do a double encoding. So we're encoding the variable by color, but also by shape, okay? And that way, even if our color blindness checks fail completely, we still have the color as sort of like or the shape rather as sort of like a fallback, okay? So if people are having trouble with the colors, they should still be able to distinguish the differences by shape. Okay, really common problems with colors. There are quite a few problems with colors. I would say the most common is people trying to map too many categories to a qualitative scale. Okay, if you get much beyond 5-ish, there's some cases where you can go up to like 8, but if you're getting into double digits, it's going to be pretty tough to distinguish. Okay, so here's an example where you can tell pretty much immediately this is too much, right? So I can look at this point and tell it's one of these ones, but I don't know which one exactly, right? It's going to be really tough to map it to that one. An alternative is to use labels, and we'll talk about this more later, but you can use GG repel where you're just saying label equals state. And then, but instead of saying geom text, I use geom text repel. And then you get a little label for each state. This is still really busy and probably not very good. Better, you could take a subset. I just took a random subset and filtered to those ones. And then you can label just those ones. But then the other thing that you, oh shoot, I thought I had this. The other thing that you can do with this is combine the highlighting with the labeling, right? So you can highlight just a couple of points and then use geom text repel to label just those points as well. Okay, the rainbow palette. The rainbow palette used to be like the default pretty much for all data viz software. It no longer is because it's pretty well recognized that it doesn't work very well. Okay, it's kind of pretty, like it's very rainbowy, right? And there might be certain situations, like if you're doing, say, an LGBTQ plus visualization and you're trying to show like some pride thing, then the rainbow palette might be the best palette that you could possibly choose, right? But generally, it's not going to work very well because of the differences are just not maximally distinct. Here's a article on it. There's many more, so you can research that some if you want. But basically, I would suggest probably in most cases not using the rainbow palette and using something else. Okay, last few notes on palettes. So again, there's tons of different types of palettes. There's all sorts of different tools you can use. Color Brewer is a really common one that you'll see a lot out there. It's built right into ggplot, so you don't have to use any other packages or anything, and you can find and use those palettes. So you can see right at the top, you have sequential or diverging or qualitative. You can say the number of cases you have. So 8 qualitative ones, and then you can click on them. And you can see this is 8 class set 1, right? So set 1 is the name of that palette. So you'd say scale, fill, brewer, and then parentheses, and then say palette equals set 1, and it would create this palette for you. Okay, so there's a bunch of different ones. You can also click on colorblind safe, and look, we have no palettes that have 8 categories that are available to us. What if we go to 5? Still none. What if we go to 3? If we go to 3, we've got the 3 different palettes. And at 4, we've got 1 palette. Okay. And there's some other things that you can do here too. But so it shows you with a map as the default. But so yeah, Scale Color Brewer or Scale Fill Brewer, that ships with ggplot and they work really quite well most of the time. So here's an example. This is set 2 from Color Brewer. Another interesting package is this Palleteer Package. This guy, Emil, he's really good. He does a lot of really neat things. This package basically tries to pull in all of the palettes from all of the various packages. And so you can see like this is all the palettes that are within this package currently. Okay. And so you can use these like this, but you can do it for ggplot like this. So scale color Palleteer D, and then the name of the package, double-colon, and then the name of the palette. Okay. Oops. All right. Okay, so that's it for today. So we are going to move on to lab 3 for the rest of the day. We have about an hour today for the lab. And this will be our final lab of the term. So we're going to have one homework that I think is assigned next week, and you'll have 2 weeks to complete that one. And the homework will be very similar to the labs. The only difference is, right, it's scored on a correct and incorrect basis. You can still work in groups, though, if you want to. And then the rest of the time, we don't have any other assignments because I'd really like you to be focusing on your final project, okay, and working together. Hopefully, you've all made some good progress there. I haven't had too many people come to me with questions about that, but we're at week 5 already, which is pretty amazing, but halfway through. Okay, so lab 3 is today. And so we're going to be looking at color, right? So you'll be asked to use a variety of color palettes and use color for the 3 main purposes that we just talked about. The data should be in the repo. It's from Tidy Tuesday again, and it's called Honey Production. Okay, so we have the Honey Production CSV file. So first, I'd like you to visualize the total production of honey across years by states. Missing the period there. So use color to highlight the West Coast. Okay, with a different color for each West Coast state. So I have a couple of hints here for you. I'm not asking for a specific kind of chart, okay, a specific kind of plot. But if you're thinking about visualizing it over time, then a bar plot probably isn't going to be the best bet, okay? And the reason I know that is because in the slides, we're talking about states, and we have a bar plot. In this case, a bar plot is probably not going to be what you're going to want to do. To get each state to be a different color, you should either map state to color for your layer that adds the West Coast states, or use the GG highlight package, okay? Then I'd like you, once you're finished with that plot, to produce it, reproduce it according to the 3 different kinds of color blindness, plus the desaturated version. Then reproduce that plot again using a colorblind safe palette. And then there's a file here that denotes the region for each state. Okay, so I'd like you to download that and then join it with your honey file and then produce a bar plot. So this is very much like the slides. Produce a bar plot displaying the average honey for each state where you're collapsing across years. So average honey for a state across the years, right? Use color to highlight the region of the country the state is from. And then note any patterns that you notice. Okay, then last 2 things, create a heat map displaying the average honey production across years by region, averaging across states within region. And then last one, create at least 1 more plot of your choosing using color to do one of the 3 things that we talked about, okay? And then I have just a little bit of extra information here. If you are interested in producing a map, I would encourage you to go ahead and try it out. Here's some very quick code to do this. So this code will give you the Albers projection of the United States. And then you can use just this code right here, and that will actually plot the United States for you. Okay, you will get a warning, but don't worry about it. It's not a big deal. This package hasn't been updated for a while. Okay, so that will do this for you. And then I'm not going to dock you any points if you can't figure this out, but it is a little bit trickier than it seems on the surface because the honey production data set actually only has 44 states. So when you're joining those, you want to make sure that you keep all the states as you're joining in the honey, okay? So that you don't end up with a map with a missing state or 2 or 3 or 6, okay? Any questions on that?